Good morning, boys and girls. Today is Thursday, November 19th, 2020. I hope you guys are doing well and hope you guys are staying safe and healthy, and I hope we can be back together soon. I have a very deep math review today. This lesson is about 4 pages long, and I need you to go get a pencil and a piece of paper so you can work these problems with me. So if you do not have a pencil and a piece of paper right now, I need you to go grab that and come back as soon as you can, okay? Okay, we are going to get started. I have a word problem for us today, and we need to dive into the word problem. We need to find the parts and the whole, and we need to solve for the missing part. So let's see what we know. First, in a word problem, you need to look for the information that is given to you. So let's see what information we have in the word problem. Hope you can see that. Okay. Blake saw 14 deer in the field. 12 of the deer were does. How many deer were bucks? So let's talk about the information that we know. We know that there were 14 deer. That is the total amount of deer that were in the field. We know that 12 of the deer were does. They were female. We are looking for the amount of deer that were bucks. Those are male. We know the whole, the total number of deer spotted, and we know the part. We are looking for the missing part. Now, we could take and we could count up, and we could say 12 plus 2 is 14, and the missing part would be 2. We could also subtract, and we could say 14 minus 12, okay? Lots of times I tell you in class, if you do not know the answer, to use an illustration to solve this problem. Well, since this number is 14, and we've been talking about teen numbers, numbers in the teens with 2-digit numbers, to solve this, you could draw 10, 11, 12, 13, 14. You could take away the part that we knew. So you would mark out 10, 11, 12. The part that's left would be your missing part. The part is 2. I hope you guys worked that with me. We solved for the missing part. You can take the part and put it back together to make the whole. The 12 and the 2 do make the 14. When we decompose the number, when we break it apart, 14 is the whole and the parts were 12 and 2. So composing is putting the number back together. Decomposing is separating the number or breaking it apart. Okay? Let's flip the chapter. All right, guys, we have been talking about tens and ones. We've been talking about 2-digit numbers. There are different ways to represent a 2-digit number.
If you have any.
Okay, we have talked about using tens and ones in previous lessons this week to represent a 2-digit number. A 2-digit number would have a tens place and a ones place. So what we're going to do this morning is we are going to count the rods and the units, the tens and the ones, and we are going to identify the number that is shown in the picture, okay? So remember, when you see a tall 10, when you see a rod, it is worth 10. The value is 10. And when you see a unit, the value is 1. So when you say the 10 rods, you're going to say 10. When you see the units, you're going to just say 1. So let's count this together. 10, 20, 21, 22, 23. One way to represent the number 23 is 23, numerical form. You could also do expanded form. 20 plus 3 equals 23. The 20 represents the tens place. The 3 represents the ones place. Now, let's count the next one. We're going to count by tens first. Let's start in the tens place. You always start from the left and go to the right. So let's start with the tens place. 10, 20, 30, 40, 41, 42, 43, 44, 45. So I definitely need to use the numerical form, 45. And then I also want to use the expanded form, which would be 40 plus 5. And remember, we talked about that this is a 4, but the value is 40. So that's why we don't say 4 plus 5. We would not use a 4 because, okay, we would not use a 4 to represent the tens. We use the value, which is 40. Okay, we're going to come down here and count the next one. 10, 11, 12, 13, 14, 15, 16. We only have one 10. So there would be a 1 in the tens place, but there is a 6 in the ones place. So we use the digits 1 and 6. The numerical form is 16. The expanded form would be 10 plus 6 equals 16. Remember, the value of the 1 is 10. Okay, let's count the next one. 10, 11, 12, 13, 14, 15, 16, 17, 18. So the numerical form is 18. The digits 1 and an 8. Remember the 110, when we break that apart, 10 plus 8 equals 18. Remember, we use the value when adding the parts together to make the whole. You use the value of the tens place, not the digit, not the one digit. You use the value, which is number 10. So if I wanted to show that in a number bond, the whole would be 18 and the parts would be 10 and 8. Okay, now we are just going to count the ones place. I did not put a 10 here because I want you to see the sun keeps shining in the window and making a glare. So I want you to see if we count the ones place, 1, 2, 3, 4, 5, 6. I wanted you to see that if we counted the ones place, you would not need 2 digits. You would only need 1 digit. So this number does not have a 10 because we didn't have enough, there's not a great enough amount to move to a 10 rod. So this number would only be 6. It would only be a 1-digit number. And then if you wanted to add that together, you would say 0 plus 6 equals 6. Okay, we're going to flip the page. Okay, I have an equation with a missing part. There are 2 ways to solve an equation with a missing part. One strategy is we can count up. Okay, so we need to look at what number we would be counting up to. We would be counting up to number 10 because number 10 is the whole. We would start with the number 6 because number 6 is the part. And we are looking for the missing part in this equation. So let's try this. Let's start with number 6 and count up to 10 and see how many spaces we would jump on the number line. So we start with 6 and we're counting up to 10. 6 is the part, 10 is the whole. The whole is the total. So we're going to start with 6 and we're going to see how many spaces to get to 10. So we're going to say 6. So let's count how many spaces we moved. 1, 2, 3, 4. So on the number line, we moved 4 spaces. So that is one way to solve for the missing part. And the number 4 would make that equation true. 10 minus 4 equals 6. But we could also subtract and count backwards. That's a different strategy. And it doesn't matter which strategy the children choose. They can choose counting up, starting at 6 and saying 7, 8, 9, 10. The answer's 4. Or they can start at 10 and count backwards 6 places. Let's try that way. So you would start at 10 and you would go back 1, 2, 3, 4, 5, 6. You're also going to land on the number 4. Either way that they choose to solve this is fine, as long as they are finding the correct answer. 6 is 4 spaces away from 10, or if we start at 10 and jump back 6 places, we find the number 4. As long as they understand that 4 was the missing part. Just make sure that if you're helping your children find the missing part, you are not adding the part and the whole together, because that will produce an incorrect answer. So don't let them do that. The last thing on this page is a fact family, but we have a different page to do. A fact family consists of 3 digits. The digits in my fact family today are a 3, a 5, and an 8. And what children need to do is they need to find the relationship between the digits. So if you have a fact family, all 3 of these digits have a relationship, much like I just showed you in the example at the top, that 10 minus 6 is 4, or 4 plus 6 is 10. So what we need to decide is we can use these 3 digits to produce 4 equations. So a child should be able to find 4 equations using the same 3 digits: 2 addition, 2 subtraction. So if you have a pencil and paper right now, I want you to make 2 addition sentences first. Let's start with the addition first and then move to the subtraction. So the addition, you take your parts, as we have discussed many times, you take your parts to equal the whole. When your children see the 3 digits in the fact family, the best thing to do is find the whole. What number am I adding up to? What is the greatest number in this set? Well, the greatest number is 8. So we would want 8 to be our whole. Our parts are 3 and 5. So let's start with the addition sentence. 3 plus 5 is 8. Now, we also need to use those same digits in a separate addition sentence. We've already used 3 plus 5, so we cannot use that addition sentence again. We need to swap the digits and say 5 plus 3. We are working hard on fact families. We're working hard on addition facts, and this is one way to help you memorize your addition facts, that 3 and 5 are partners of 8. Now we're going to do 2 subtraction. When you subtract, you start with the whole. The whole goes first. So you would say 8 minus 3 equals 5. Now we need to flip these, and we need to say 8 minus 5 equals 3. So there are 4 equations in our fact family. Very important you understand the relationship that 3 and 5 make 8, 5 and 3 make 8. 8 minus 3 is 5, and 8 minus 5 is 3. All of those digits are interchangeable. The parts are interchangeable in the fact family. The whole remains the same in each equation. Okay, in our last page today, we are going to look at doubles facts and doubles plus 1. If you have a doubles fact, the 2 add-ins in a double are the same. 2 plus 2 is 4. Both add-ins are a 2. We call that a doubles fact. Doubles facts should be memorized without counting on your fingers. You should know 2 plus 2 is 4, 3 plus 3 is 6. Those are automatic facts that should be stored in your brain. You should have those memorized, not counting on your fingers. So we want to learn to use doubles facts and doubles plus 1. If I say the doubles fact is 2 plus 2, then the double plus 1 would be 2 plus 3. The reason we need to learn doubles and doubles plus 1 is those addition facts have to be automatic by the end of first grade. If you know 2 plus 2 is 4, count up one more. 2 plus 3 is 5. It's an easy, quick way to help you memorize the facts. Now, I also want us to learn that every time I see a double, the answer is going to be even. 4 plus 4 is 8. The answer is even. When both of the add-ins are the same, the answer will always be even. So if 4 plus 4 is 8, we're going to count up one more. 4 plus 5 is 9. Boys and girls, it's just like thinking like this. 8 plus 1 equals 9. We're just adding one more. We're counting up one more. This is so simple, and I just want you guys to know that the more you practice, the easier it will be. So no more counting on your fingers. Use your doubles facts. Use your doubles plus 1. What's 5 plus 5? 10. So you need to recognize if 5 plus 5 is a double, 5 plus 6 is a double plus 1, so 5 plus 6 is 11. Remember, doubles facts will always be even. 6 plus 6, 12. 6 and 6 are the same. The add-ins are the same digit, so you would call that a doubles fact. Now, let's think about 6 plus 6 is 12. Perfect. We all know that. Great. But what would be the doubles plus 1 fact to match that? Well, if this is 6 plus 6, the doubles fact plus 1 would be 6 plus 7, because 7 is one more than 6. The total number is just like I mentioned earlier, 12 plus 1. So if 6 plus 6 is 12, one more is 13. And you should also notice a pattern on the end, on the sums. It's a pattern, 8, 9, 10, 11, 12, 13. Each time we add a double and a double plus 1, it's in numerical order, 8, 9, 10, 11, 12, 13. The numbers are getting bigger. The next number the next fact in the sequence would be 7 plus 7 equals 14. That would be the next double. Thank you for joining in. I hope you were able to work the problems with me. Tried to slow down a little bit today. If you have any questions, please let me know. I hope you guys tune in to our Google Meet today at 2:15. And I had 5 precious tiger cubs on the Google Meet yesterday. And I would love to see your sweet little face today. Goodbye, friends. Stay safe, stay well. I miss you.